Hey folks, this is your TA Graham Edwards, and I am going to introduce to you an overview of the lab practical project for Earth 127. Over the course of this class, I will take you through the process of collecting various isotopic data for a geological sample, which you will then have the opportunity to interpret to reconstruct the geologic history of that sample. You'll be working with brand new data collected for an active geochemical study, placing you all at the cutting edge of earth science research. The subject of this quarter's lab practical is sample M09B176R, which I will call B176 for short. This sample is a carbonate rock that formed in subglacial waters beneath the extinct Laurentide ice sheet, which covered northern North America during the last ice age up until it began to collapse a little after 20,000 years ago. While the Greenland ice sheet survived, all that remains of the Laurentide ice sheet are a few small ice caps in the Canadian high Arctic, including Barnes ice cap on Baffin Island in the Canadian archipelago. Sample B176 was collected on Baffin Island near the northeastern margin of the Barnes ice cap. The Barnes ice cap contains Pleistocene ice from the Laurentide ice sheet as well as younger Holocene age ice. Like most glaciers, ice caps, and ice sheets, the Barnes ice cap contains a bottom layer of sediment-rich basal ice at the interface between the ice and the rocky bed underlying it. The surrounding landscape of Baffin Island boasts a barren, recently deglaciated tundra. A field team of researchers collected a number of rock samples near the Barnes ice cap margin during the summer of 2009 for a glaciological study. Several of these rocks included carbonate sedimentary rocks that had formed on the surface of glacially eroded silicate rocks near the Barnes ice cap margin. These rocks come in a variety of shapes and sizes, but likely all precipitated on the surfaces of these boulders from subglacial waters when this area was previously covered by ice. A series of papers published between 2012 and 2014 confirmed these origins from subglacial waters when the Laurentide ice sheet was at its maximum extent at a little over 20,000 years ago. So-called subglacial carbonate precipitates have been observed in a variety of glacial settings and form when subglacial waters rich in dissolved ions become concentrated enough, often by freezing of fresh water, to drive calcium carbonate precipitation. These subglacial precipitates can be important archives of ancient glacial and subglacial processes. So, this quarter, we will be collecting isotopic data on the beautiful subglacial precipitate B176. But before we can make isotopic measurements, we must first make physical observations of the sample and prepare it for subsampling for isotopic measurements. This view shows the upper surface of the sample with lineations parallel to the direction of ancient ice flow. This view shows a cross-sectional view revealing two distinct layers. These two layers motivate a key hypothesis, that both layers record two distinct time frames of carbonate precipitation. We will test this hypothesis later on with uranium-thorium geochronology using measured uranium and thorium isotopes. But first, we will subsample multiple layers of B176. To do this, we will isolate a thin column of the sample by cutting it out with a rock saw. Hey folks, TA Graham here. I'm going to show you how we slab rocks or cut rocks on the rock saw. We call it slabbing because we'll cut them into slabs that we'll work with. So this over here is a rock saw. There is a water bath sitting below here, and then there's a saw up here. This saw isn't serrated like a saw we use for cutting wood. It is encrusted with diamonds, so it's actually not sharp. But because of those diamonds, it has a high hardness, and so it can actually abrade its way into a rock using those diamonds. So what I'm going to do is I will put this little shield arm down, I'll turn the saw on, and I will cut my rock. Of course, we want to have our water splash protection, our eye protection, and this is going to be loud, so our ear protection. Once we get this on the saw and get a piece cut out of it, we can look at our sample more closely and identify where we want to subsample from there to move on to our isotopic analyses.
You can see the water dripping out here, so that's keeping the saw cooled and lubricated. And now we'll send the rock to its fate. And that's it.
After sawing out a cross-sectional slab, we then cut out a column of the sample. We take a piece of the bottom layer, which we will call B, and subsample the upper layer A into 5 sublayers, going from A1 at the top to A5 at the bottom, just before B. We can accomplish this subsampling either with the rock saw or with hand tools. Then, we powder the sample by crushing in a mortar and pestle or by grinding with a Dremel power tool. We collect all our powders in well-labeled vessels, and then they are ready for aliquoting for isotopic analyses. We'll show you these procedures in the upcoming videos. See you then!